Now let's take a look at this thing called an O-ring. It's another type of a seal. This is a clapper. It's a seal. When it's all the way down, water cannot get from the backside to the inside. It's sealed right along there. So it stops water from getting from one side of the check to the other side of the check. But there's another pathway for water to go. It can go around the outside and basically leak through all these little threads and go around. That's what this O-ring is for. It's a piece of rubber that will seal the outside. Now, it's not quite as fancy as this because it gets in there and jammed in and tightened up and sealed, and it doesn't have to always be opening and closing and doing stuff like that. People also seal with plumber's putty and Teflon tape and all that kind of stuff, but this is the seal of choice for this job, and it's called an O-ring. Basically, let me see if I can take a look at it here. It looks like that. It's a rubber ring in the shape of an O. It's an O-ring. And there's tons of these that are standard. They're made. This one's called a size 358. And so if I look at my book about these, you can see that it's static. It's not moving. And I'm keeping, it's on a piece like this. It's not internal. It's external. And the piece is going into a tube. So this is the situation we've got. Okay, so I want to use the B1, C, and A design diameters. Now, we're not meeting exactly the A and the B1 because of the manufacturing process that we're using to make the parts. But we're very, very close, and we have found that the seal does work. Okay, so let's go find one that fits. Okay, and this diameter here is like 5.6, and this diameter is 6 point something. So let's go see. We can keep going down here, and look, there's all different sizes that I could use. I could even use. I think what I'm using is the 258, the .210, but might even be able to find one in this range too. But let's just keep going until we see a 358. Here's the number, and these are Parker numbers, but they follow a standard, an O-ring standard. So I'm just keeping going. Oopsie, that jumped a little too far. Go look for 358. There it is right there, 358. Okay, so this says the ID should be 5.6, and we're 5.620. We made the fit a little bit tighter. Okay, so we're at 5.620. And its OD is 6.020. Okay, so and that comes out pretty close. And so the seat, the B1, they say it should be 5.660. Ours is 5.620. Okay, so we don't match this exactly, but this is very, very close. Let's see if this one is a little bit closer down here. 5.620 on the B1. No. So this one's a little bit worse. So that one was the best one. Okay, 5.673. Okay, so this is the best one for us to use. It's a 358. So when we model it, we would model it with an OD an OD of 6.020 and an ID of 5.600, which will give us a mean dimension of 0.210 cross section. Okay, so that's how we do it. And the goal then is to create this and put it in. Now I'm going to show you there is a tiny little speck in the middle. One weird thing about Inventor is when you do a revolve, you either have to add an axis or add a tiny little part that you can do lining up with. So I chose to add a tiny little inconsequential part that when I do an assembly, it will add the axis for me. Okay, and it doesn't make any problem for my drawing or anything like that. So instead of adding an axis for me to line up to, I did a little tiny part. And this is like 10 thousandths of an inch diameter. So it doesn't really make any difference to this thing at all. So there we go. That is how O-rings work. The best thing to do is to get into this Parker handbook and really sort of figure it out. You have to look at the drawings and see, okay, how does that work? How does the groove work? What does it look like? How does all of this kind of do? Okay. And so this male gland is the one that works with us. This is a normal groove, and we're not doing that. Ours is a very simple groove. We're not doing that. And we're doing one-way pressure, but we are not using a parback ring. We're just letting it jam in there against it. And we had great success with that. Okay, there we go. That's your little start looking at O-rings.